All right.
Maybe he be killing people's boss.
So, here we go. Here we go. You might have seen these before. Do any of these look familiar to you?
Yes.
Growth formula, decay, compound interest. Yes?
Okay.
Okay. So you have done these before. The one thing that you have not done before is you have not solved for t. You've not solved for the exponent. The reason you have not done that is because it requires taking a log, and you just learned how to do logs. So what do you think that we're going to focus on when we do these problems in Math 3? We're going to focus on solving for t. Does that make sense? So we're going to have some easy problems that are kind of like back in the day when you first learned these and you just plug all the numbers and get the answer. We're going to do that. We're going to get some easy points. But we are mainly going to focus on the problems where they ask us how much time it took to do something, because time is the variable that goes in the exponent, and that's what we just learned how to solve for. That's a new thing for us, and so that's what we're going to do in a lot of the problems. Does that make sense? How that's like different than what you guys have done before? Okay, so when we look at these formulas, the growth and decay formula are very similar. For the growth formula, you're going to see words like increase, and they might say appreciate in value, which doesn't mean appreciate like I appreciate you, it just means it goes up. For decay, we're going to see words like decrease or depreciate. So that means it lost value. Like a car, as soon as you buy a new car and drive it off the lot, it depreciates in value. It's not worth the same amount. Right? The formulas might be a little different. The letters might be a little different from what you've seen in the past. And what I did is I made it, because all these formulas, some teachers use some letters and some teachers use the other letters. It kind of looks, it depends on where you look it up online. And I just wanted you guys to see how similar all these formulas are, because if you notice, they have a lot of the same letters in them. Are you guys seeing that? We got a lot of the same things in there. So y in all of these problems, it's y equals, y equals, y equals, y equals, y equals. And y means the same thing in every single problem, and it means the final amount. So y is the final amount. Does anyone remember what p is right here? The initial value, and sometimes they would call it the principal value. That's why they use the letter P. So for me, principal value doesn't make a lot of sense, so I'm just going to say P is the initial value. You might already, or you might also say starting point, if that makes more sense to you. So Y is the final value, P is the starting value. They might say that you start with $200 in an account, and they might ask what you end with. And if they phrase it like that, then 200 is the P and what you end with is the Y. That's what they're getting at. Anyone remember what the R is for? What is the R right here? Rate. R is the rate. And does anyone remember what's special about the R? It has to be written as a decimal, okay? So put that in capitals, underline it, highlight it. Has to be a decimal. So if we have 5%, what is that as a decimal? 0.05. If we have 2.5%, what is that as a decimal? 0.025. If we have 10%, what is that as a decimal? 0.10, yeah, 0.10. So we have to be careful when we use the rate that we use the decimal version of the rate. When they give us the problem, they're always going to give it to us as a percent. When we type it in our calculator, we have to use the decimal. If you don't use the decimal, your answers are going to be ridiculously large and your answers will not make sense. Okay. Anyone know what the T stands for? I almost said time. T is time. And it is typically in years. Typically in years. Does anyone know what the n is in here? So compound interest formulas, they might say that the interest was compounded quarterly, or it was compounded monthly, or it was compounded weekly, or it was compounded annually, or semi-annually, or daily. So what's the n?
Like the period of time.
The period, kind of, yeah. It's the number of times per year. Okay, so the n is the number of times usually per year. And just so we don't forget, we're going to write a few of these down. So if they said something about daily, then what do they mean? How many times per year? Yeah, 365. There's 365 days in a year. What if they said weekly? 52.
Whoa.
What if they said monthly?
12.
12.
Yeah, I got that right.
What if they said quarterly?
25. I mean, whoa.
4. Yeah, no, you were right. You were thinking the right thing. Quarters, there's 25 cents, but there's 4 quarters in $1. So quarterly means 4. 4 of them. Anyone know what semi-annually means?
Half a year.
Half a year, it's twice. Oh, put an I in there. Semi-annually means twice. Okay. You guys are so calm when I videotape. Maybe I should just videotape every period, all period long.
No.
Would that help? We just be like super quiet. All right. How about this letter E? What does this letter E stand for?
Every day.
Every.
Is it a variable? Does it stand for something? No. What is the E?
A base.
It's a base. It's a number on your calculator. This is not a variable. But you guys were right. It's the opposite of ln. So when we do this, when we do these compounded continuously problems and we are solving for t, you're going to see an ln in the problem instead of a log in the problem. Right? So anytime we tootsie roll a problem that has an e in it, we're going to see an ln instead of a log. Okay. Half-life. Does anyone, what does that remind you guys of? Half of a life. Have you guys done this in science at all?
Oh,
Half-life formula?
yeah.
You might have seen it. In science, they do the formula a little bit differently. It works out the same. The answers are the same, but their formula is a little bit different. What do you think the H stands for?
Half-life.
How long a half-life is. Okay? So H is how long a half-life is. So if they say the half-life of carbon is 400 years, then if you start with 20 grams of carbon, in 400 years you will only have 10 grams left. So its half-life tells you how long it takes for half of it to disappear. Okay, so that's what that formula does. All right, we got the formulas. Now we're going to move on to the story problems. Stretch out your hands, get them ready. We're about to write a lot of words. You guys ready? Story problems, we're writing a lot of words. Whew. All right. So here is the problem. A city has a population of 6,076 in 1990. Were any of you guys born in 1990?
Yeah.
You're too young for that, right? You were born after 1990?
I was born in 2002.
Oh, 1990 would be like teacher age. You guys were born in the 2000s.
No, I was born in 19.
I'm a little bit off, yeah. In 1990. And grows. And grows by 3.7% per year. My math was a little bit off there.
Roger, why are you over here?
Thank you, I appreciate it. You saved me from having to say it. How many people are there in 2025?
A lot of people.
I told you I got bit by a dog.
Why are you talking about getting bit by a dog?
She asked me why I had a hole in my pants.
Goodness gracious.
Um,
All right. So a city has a population of 6,076 in 1990. It grows by 3.7% per year. How many people are there in 2025? Probably not 6. It grows. It grows, Philip. All right. So if we look at our formulas, this is how we narrow it down with our formulas. Do you see the word compound in the problem?
no, that's
No.
the word term.
We're not using these two. It doesn't use the word compound. We're not using them. Does it say the word half-life?
Oh no, it said the word grows.
Yeah, so we're not using the bottom three because none of these words were used. Now, that means that we only have either the first one or the second one, and it uses the word grows. So it's going to increase. We're going to use this equation right here. So I'm going to go ahead and write the equation out, and then I'm going to figure out what each letter should be. All right, so y is the final amount. Did they tell us what the final amount is? No, that's what we're solving for. Y equals question mark, that's what I want to know. P is the starting value. Did they tell us the starting value? 6,076. Perfect. R is the rate. Did they give us the rate?
3.7%.
3.7%. And what is that as a decimal? 0.037. T is the time, usually in years. Did they tell us how many years?
Yes, technically 35.
Yeah, we gotta do a little bit of math, right? From 1990 to 2025 is 35 years.
That's a lot of years.
It's a lot of years. I mean, it's not like too many years. It's like a reasonable. You're still young if you're 35. You know what I'm saying?
35 is old.
Whoa, whoa, whoa! What you got against gray hair?
35 is old.
Rude.
It is old.
I know whose grade I'm controlling.
Mom's like
All right.
45.
Y equals.
Wait.
What should I write next? Yeah, so we've got P, that's 6,076, times 1 plus 0.037 to the
T.
35. All right, it is ready for you to plug in. Go ahead and plug it in. I should hear some clicking because you're typing on your
You put it
calculator.
in Y equals, right?
Huh?
You put it into Y equals, right?
No, you don't put it into Y equals. You don't need to graph it. You just need to see what it equals. So do not plug it into Y equals. We're not graphing. We're just typing it in on the main screen.
21,670.76481.
Yeah. All right. Now this is people. It is a lot of people. But think about cities. Cities are usually pretty large. 6,000 is actually very small for a city. That's a very small city. Should we do a decimal for a number of people?
No.
No. So we're going to round this. What's the nearest whole number? We're going to round it up. Why are we rounding it up?
Because you can't.
Can't have half of a person, and it's 0.7, and 0.7 tells us to round up. Now, these are story problems, so story problems get story answers. So we write our answers as a sentence.
Oh my.
Okay? So I'm going to go ahead right here. I'm going to say y is approximately, and I'm going to write down this decimal answer. And then when I write it as a sentence, I'm going to go ahead and round it before I write it as a sentence, okay? So this is me doing a really good job of showing my work so that whoever looks at my paper can see exactly what I did and exactly what I was thinking.
follow the teacher, I'll give you 100.
Thank you. I appreciate that. So how many people are there in 2025? There are about 21,671 people in 2025. Why did I use the word about?
Because it's not exact.
It's not exact. There are about 21,671 people in 2025. So when we do these story problems, we get story answers. We're always going to write a sentence. Shelby, if you need to punch him, I'll look away for a second. You're welcome. I know I did. You can send it to my mom so she can't hear it when she watches it. All right, here's the next question. How long will it take? So this is part of the same question. This is just another, we're just going to solve for something else. How long will it take for there to be 25,000 people? If it's tomorrow, that is a lot of pregnancies real fast. I don't think it works like that.
It was getting groovy.
How long will it take for there to be 25,000 people? So which variables are we do we have now that we did not have before? We know we have y now. This time we got y equals 25,000. We did not have that before. What variable did we have before that we do not have now?
P.
T, yeah. It says how long. That's a question about time. So this time t is what we don't know. So we are going to rewrite this equation. We're going to say 25,000 equals that starting value. That starting value is going to be the same. We still have the same rate. They didn't tell us anything in the problem that makes us think that the rate changed. And this time we're going to have t as an exponent. Ooh, that was super zoomed in. Okay, so I need to get this t alone. What should I do first? Divide. Yeah, what am I going to divide by? 6,076. So this number right here is being multiplied. We need to undo it. We want to move stuff away from t, so I'm going to divide by 6,076. Now we can see if this is going to be a nice number. Does it end up being nice? It does not. So if it's not a nice number, are we going to round it right now? No, get out of my class. Bye. All right, this is not a nice number. This is not a nice number, so do we want to use the decimal right now? No. So we're going to use this fraction. We're going to leave this fraction right here.
I knew what you was talking to. I could have just waited. You were loud too.
Roderick, now you know how it is when you talk.
That's on video.
All right, what did I do right here? Yeah, I combined those together. We can just add those numbers. They're inside the parentheses, so it's okay to add them. And now we are at the point where we are ready to do the Math 3 version of this problem. So we have an exponent we can't get to. So how do we undo this exponential form? We do a logarithm. What's the base of the log? 1.037. And this time, what's weird about the Tootsie Roll this time?
You don't have a what does it go to?
You do.
T.
No. When we Tootsie Roll this time, we got to go backwards.
Oh, yeah.
We're used to the equation being written the other way. So our Tootsie Roll this time is going to go backwards. If that is uncomfortable for you, just flip your equal sign. You can write it the other way if that makes you feel better. So log base 1.037 of this fraction, the 25,000 over 6,076 equals t. Have we figured out the number of years?
39.
Yeah, we just solved it, right? T is alone. Now, is somebody going to write a sentence? They're going to say, it takes log base 1.037 of 25,000 over 6,076 years
No.
to have 25,000 people. Are we going to phrase it like that?
No.
No, we are not. So let's go ahead.
It sounds smart.
You could sound smart or crazy. We're going to go ahead and type this in on the calculator. Can you have a decimal year?
No.
You can't?
Oh, you can.
You've never told
actually.
somebody you were like 8.5 years old back in the day?
No.
You never told someone you were 8.5?
I'm 13
You,
and a half.
13 and a half. Okay, not 8.5, but 13 and a half.
I didn't know you could be 13 and a half.
All right, so go ahead and type it in.
I thought you was in 13.
No.
So what's 13 and a half?
When your birthday is halfway there.
Well, in that case, I'm 17 and a half.
You 15.
Whoa. Taking it too far. Now you got to say 3 nice things. All
That
right.
was 2, 4, 5.
So typically we're going to round to 2 decimal places usually. So let's go ahead and do 2 decimal places. What should they be? 38.93. Good. What are the units? Days, months, years? Years. Okay. And then do we call that good? Is that a good final answer? No.
Ooh.
We're going to say, how long will it take for there to be 25,000 people? I'm going to write. It takes about 30. Whoa, sassy. 38.93 years for there to be 25,000 people.
What if you rounded up to 39?
39 would be okay. It kind of depends on the instructions and the problem. So in the instructions, I might ask you to round to do 2 decimal places. And if you round it up to the nearest whole number, then I might take off like half a point and say you didn't round like I told you to. But then other than that, you're right. Like mathematically, you still found the right answer. Okay. All right. How do we feel about that problem?
Pretty good.
Pretty good? Okay. Now, we're going to write a little note to ourselves. We're going to say exponential decay is similar. There's just a minus instead of plus. So we're not going to do an example of that because no need to get a hand cramp. Okay.